Good morning, eighth graders. We are going over what is listed as chapter 4 in our tectonics iBook. Okay, so we've talked about what tectonic plates are made of, what causes them to move around on the surface of the earth, right? It's the convection of the mantle, heat rising from the core, moving laterally, sinking, heating up, rising, moving laterally, and all of those convection currents that are happening inside, inside the mantle. All of those little convection currents that are happening push and pull and move all of the plates around. And they, depending upon how they move, they will cause different things. Okay, we're going to talk first about earthquakes. And earthquakes happen mostly at convergent boundaries. So that's the ones that are coming together. And in particular, when it's continental and oceanic crust, okay? So when you've got a boundary that is continental and a boundary that is oceanic, the oceanic is denser of the two, so it will subduct, okay? Those subduction zones, and I'll show you a map of where they are, they're found all over the world, and those are areas that have a lot of earthquakes. Another boundary that is common is at transform boundaries. So those boundaries that are moving side to side, okay? So we're just going to talk about some features of earthquakes and how we study them today. And it starts out with a picture of San Francisco. San Francisco looks a lot different from this now, but in 1906, they had a very big earthquake. The greatest damage that was done in San Francisco in 1906 was not from the ground itself shaking, but from all of the after effects. And that is still the same today. It's not necessarily from the shaking that happens, but it is from things like gas lines breaking and water lines breaking and rubble being piled up, and then the aftershocks, all of those continued earthquakes that happen afterwards can really be dangerous. Okay, so what happened in 1906 was the gas lines broke in San Francisco and a huge fire started. Well, when they went to put the fire out, the water lines had also broke. And so that put them in a pretty tricky situation. An earthquake is a sudden ground movement caused by a release of energy stored in rocks. Okay, so you can think of it as, here's my meter stick. Meter sticks have a little bit of flex, right? Well, rocks do too if you are as strong as the earth, right? The earth movement, the tectonic movement can actually bend and flex and stress rocks to a point. If I continue to bend this, it will only flex like this to a point and then it will release. There's a lot of potential energy here, right? If I continue bending, that potential energy is going to turn into kinetic energy, energy of motion, and this meter stick is going to snap and send two edges flying and wobbling, okay? Same thing happens with boundaries of tectonic plates. Okay, the rock is moving past each other. Well, the rock is going to catch at some point, okay? That rock catches, potential energy builds up and builds up and builds up over time. Well, eventually it can't build up anymore and it will snap. And when that happens, we have earthquakes. Another thing that happens is that when two plates are converging, they're coming together and one subducts under the other one, the subducting plate kind of drags that overlying plate. And so it'll drag this edge of that overlying plate, and it'll continue to drag it and continue to drag it and continue to drag it until pop. This will pop, and when that pops, we have an earthquake. Okay? So the chapter goes on talking about something called the elastic rebound theory. Okay, so that says that stresses build up on both sides of a fault. A fault is a break in the rock, okay? And it causes the rocks to deform plastically. they're a solid, right? They're very, very rigid. And when you put a whole bunch of stress on a rock and you're trying to bend it and bend it and bend it, if you are as strong as the earth, you'll be able to kind of deform it, not bend it, but deform it plastically to a point. And eventually so much energy will be built up that it will snap. When the stress becomes too great, the rocks break and end up in different locations. Okay, so this is kind of showing that. You've got a road here, okay, at normal. Over time, this plate is moving this way, this plate is moving this way. Eventually, that stress is going to buckle, and you are going to end up with half of a street over here and half of a street over here. Not a big deal unless your house happens to be right there. Causes buildings to fall down. Okay, so here's a guy who is doing the same little demonstration that I was just going to do.
What do you mean? Well, an elastic material is something which you can bend. You put a force on it, you can bend it, but if you take the force away, it will go back to its original shape. So that's elastic. When we speak of a brittle material, what we mean there is that it's an elastic material, but it's got a limit to its strength. And so we take a yardstick, which is a really good model for a brittle material. So what we can do here is the yardstick, which is brittle, is elastic up to a limit, can bend it, take the force away, it goes back to its original shape. But if we get too energetic with this and bend it too far, then, of course, what's going to happen is it's going to fracture. So that was the limit. That was the brittle behavior. Elastic up to this limit of strength, and then pow, it breaks. So in essence, I just made an earthquake. I fractured this thing. I made an earthquake in this yardstick.
Okay. There's a couple terms that I want to discuss with you that seismologists are those who study earthquakes. They have to use these two terms a lot: focus and the epicenter. Okay, and we'll be defining these terms in class, but here's my model of the earth. The break in the rock, where the rock actually fractures, is underground, right? That wave of motion will vibrate through the ground, and it might crack up here on the surface of the earth. But the original shift or break in the rock happens underground, okay? That spot is called the focus, okay? If you have a kiddie pool, okay, picture this as one of those plastic pools that you have out in the yard, and you fill it with water, and it's completely calm on the top. And you tap the center of that pool of water, you are going to send waves out in all directions, right? Ripples out in all directions. Same thing happens with seismic waves. There's a break in the rock at the focus, and it's going to send waves out in all directions. Now, just like waves as they move across a pool of water, they lose their energy the further they get from the initial disturbance of me tapping the water. Okay, so if seismic waves are moving throughout the earth, wherever is closest at the surface of the earth to that original break in the rock is going to receive the most damage or the most shaking. Okay? And so that is considered the epicenter. That is the area directly on land, directly above the focus. The epicenter is the area on land that has the most shaking, and that will happen on the surface of the earth directly above where that original break was, and that original break is called the focus. In about 75% of earthquakes, the focus is in the top 10 to 15 kilometers of the crust. Shallow earthquakes cause the most damage because the focus is near where people live. Same idea. If you've got a really deep break in the rock, that wave has a longer distance to go till it gets to the surface, and the whole time it's traveling, it's losing energy, right? If you've got a really shallow break in the rock, it doesn't have to travel very far, and that wave is still very strong. when it reaches the surface of the earth where we have rigid buildings and roads and sidewalks, and it crumbles and cracks and shifts everything. The epicenter of an earthquake is reported by scientists and the media. Okay, so we always want to know where this spot is. And it's important to know where this is, because if we know where this is, then we know where these big breaks are, right? We can look around the world after an earthquake and find out which area had the most damage. That's usually fairly obvious. But we want to know underground, where are these big breaks happening? Because if a big break happened right here, the chances are that area is probably going to shift again. And so we would want to pinpoint where this is by finding the epicenter. Okay? And that's a skill that we will work on in class here. In the interest of time, I'm not going to go through this video and show you that. I'm going to save that for our next class time together. It's called Earthquake Epicenter Triangulation. Sounds super scientific, huh? We're going to walk through how do scientists, after feeling an earthquake, how can they figure out where exactly the break in the rock happened underground? It's kind of an interesting science that these people do. So we'll practice that together. I'll show you some real seismograms, some real maps of the waves, the seismic waves that have traveled through Earth. We'll talk about some significant earthquakes that have happened. Okay. And for the rest of this chapter, I'm skipping this. I'm going to come back to this video on our next lesson. But to conclude this lesson, I'm going to post this video right on the Google Classroom, right alongside this lecture, and post this question here. What is the San Andreas Fault? Okay? I will talk to you soon.